Every mission begins with a question, something we don't understand about space or Earth.
Scientists submit ideas, discoveries, and puzzles that need better tools to solve.
NASA gathers experts to ask, is this question important enough to answer from space?
The idea becomes a roadmap, goals, possible instruments, a target, and a dream.
Some questions orbit planets. Some study galaxies. Others aim straight at the sun.
Next, a concept takes shape. What kind of spacecraft could answer the question?
Engineers draft rough ideas, sensors, solar panels, orbits, or landing plans. Then it's formal. The team proposes the mission to NASA.
Many apply. Only a few will be studied. Fewer will fly. NASA selects top proposals for detailed study and evaluation.
Experts check everything: science value, risk, cost, tech maturity.
Scoring decides what lives and what gets shelved for now. The chosen few enter Phase A, the start of serious planning.
It's collaboration between scientists who dream and engineers who make.
Trajectory teams begin mapping the spacecraft's route, precise and unforgiving. Sometimes the payload exists. Sometimes it must be invented first.
Every decision balances cost, complexity, time, and risk.
Funding is limited. The mission must justify its price with precision.
When a mission clears Phase A, it's officially on the road to space.
Engineering begins with raw materials and precision. Electronics become the nervous system of the spacecraft.
The structure must survive launch violence and space silence. Prototypes fail, so the real spacecraft doesn't.
Launch shakes harder than any earthquake.
Artificial suns test power systems meant for deep space.
Communication is tested over distances that mimic space.
Millions of lines of code decide how the spacecraft thinks.
Engineers intentionally break systems to see how they recover.
Redundancy means failure, doesn't mean death.
Here, space is recreated on Earth.
Once approved, the mission enters detailed design, where ideas must obey physics.
Engineers model every panel, wire, and joint before metal is ever cut.
Instruments are positioned carefully. One wrong angle can ruin years of science.
Trajectory teams calculate paths that must be perfect millions of kilometers away.
Every gram matters. Mass limits shape what a mission can carry. Power systems decide how long a spacecraft can survive and work.
Heat and cold are constant enemies in space, and both must be managed.
Engineers design antennas to whisper across the solar system.
NASA ranks every risk, planning solutions before problems exist.
Design is compromise. Science dreams meet engineering reality.
The spacecraft's identity slowly takes shape.
Budgets are checked again, because space rewards discipline.
Schedules stretch across decades, not months.
Some parts exist only to prove an idea can work.
Science instruments must measure the universe without lying.
Protection from radiation becomes part of the structure itself.
This is the last chance to catch mistakes before reality begins.
With approval, design becomes commitment.
From here on, the spacecraft must be built exactly as planned. The mission is no longer an idea. It's a blueprint for reality.
Data replaces guesswork. Small changes can save entire missions.
Everything must fit perfectly, and there's no room to adjust later.
The spacecraft wakes up for the first time.
Code meets metal. Weeks of testing simulate years in space.
The design proves itself.
Now the real spacecraft is built.
The mission is ready for full-scale testing.
If it survives this, it can survive launch.
Sound becomes a weapon during ascent. Extreme heat and cold test endurance.
Radiation slowly damages everything in space.
Core temperatures are fluctuating rapidly. We are seeing peak voltage spikes across Array 7, maintaining saturation levels.
Failures are rehearsed until responses become instinct.
One degree off can mean silence forever.
NASA practices the entire mission before launch.
Every second is scripted.
The Q3 projections are solid based on this raw data.
And the regional impact?
Nothing flies without proof. Problems are hunted, not ignored.
Solutions are verified again and again.
All right.
Passing tests builds confidence.
This is the final gate.
many names carry one responsibility.
The spread leaves the lab for the last time.
From clean room to launch site.
Space is close.
Nothing is assumed.
The mission has earned its chance.
Orientation matters.
The spacecraft's final shell awaits.
This is a one-time connection.
Once sealed, access is gone.
The journey to space begins on wheels. The spacecraft meets its ride.
Fuel is handled like explosives, because it is.
Nature always has a vote.
The spacecraft receives its final instructions.
Everything must wake up cleanly.
This is launch without ignition.
Only a few bolts hold everything back.
From here on, machines take over.
There is no pause button now.
The rocket prepares to awaken.
The idea leaves Earth.
A question becomes a spacecraft.